Welcome to the next lesson on arithmetic series. Now I've got 10 examples today, so hopefully this video doesn't go for too long, so I'll try and keep it moving quite quickly. The first thing is that the syllabus states that you need to know how the formula for the nth term is derived. And then next lesson I'm going to show you how the formula for the sum of n terms is derived. So in an arithmetic series, that's one in which there is a common difference between each term. So D is usually the letter that we use for the common difference, and then A is always going to be the first term. So if A is the first term, then T1 is A. And if we add on a common difference, the second term becomes A plus D. If we add on another common difference, you get A plus D plus another D, which becomes A plus 2D, etc. We're going to add on another D each time. And notice each time as well that the number of D's is one less than the number of the term. So that's where we get this general formula Tn is equal to A plus n minus 1D. So this is the formula, and then that's how it's derived. So you can also notice that if we were to take the difference between two consecutive terms, so T2 minus T1, you get the common difference. Likewise, T3 minus T2. If you do A plus 2D minus A plus D, you're still left with D. And that's what this is saying just here. That for any consecutive terms in an arithmetic series, then the common difference is just T2 minus T1 or T3 minus T2, etc. Okay, some examples. So the first example says find the 16th term of this series. So in this series here, A, the first term is 6, and you can see D, the common difference, is 10 minus 6, or 4. And you can also see the difference between these two terms is also 4. So we want to find the 16th term, which means we're finding T16. And so that's going to be A plus n minus 1, which is 15D. So A is 6, and we have 15 times 4. So what's that, 66? It is. 16th term is 66. In number 2, find the 100th term of this series. So we can see in this series the first term is negative 4, and the common difference you can see is 2 minus negative 4, which is 6. And you can see that's also the difference between those two terms. It's probably worth pointing out as well that the common difference could be a positive or a negative number. Likewise, you can see here that the first term is negative. So the first term could be positive or negative, and the common difference could be positive or negative. So using our formula for the nth term, so that's the one you just wrote down from the previous page, we want to find in this question the 100th term. So T100 is negative 4 plus 99 times 6. And then just putting that in your calculator, you should get 590. Alright, the next example, which term of this series is equal to 320? Alright, so it's asking us to find n. So which term, Tn of what is equal to 320? So our first term is 2. What is our common difference? Well, it is going to be 5 minus 2, which is 3. And our Tn is, our nth term is 320. So we want to find what term that is in this series. So using our formula, Tn, the nth term is A plus n minus 1D. Let's substitute in there. So we've got 320 equals 2 plus n minus 1 times 3. So we are going to minus 2 from both sides. And I'll just put the 3 at the front of the brackets, it might be easier to see. And we're going to divide both sides by 3. So we get 106 equals n minus 1, and then we'll add 1 to both sides. So it's going to be the 107th term is equal to 320. Okay, in number 4, how many terms are there in this series? Alright, so we have, starting at 3, so A equals 3, we have our common difference of 10 minus 3, which is 7, or 17 minus 10. We have our nth term is 157. So this question as well is asking for us to find n. So we'll have 157 equals 3 plus n minus 1 times d. I might just put the d in front of the n minus 1 there. Alright, so we're going to minus 3 from both sides. And then we'll divide both sides by 7. And you'll get n minus 1 equals 22. And then you can say, and then add 1 to both sides. So therefore there are 23 terms in that series. 5, halfway through the examples. Is 102 a term in the series with the nth term, Tn equals 3n plus 1? So remember n is an integer. So n represents, if it's the first term, n represents 1. If it's the second term, n represents 2. So we want to see if 102 equals 3n plus 1. If when we solve this equation for n, minus 1 from both sides, if n is an integer, let's divide both sides by 3. And no, n is not an integer. So, therefore, 102 must not be one of the terms in this series. In this series. Okay, next example. Okay, now the question's starting to get a little bit more interesting. If 3 plus x plus 19 plus ... form an arithmetic series, find the value of x. So this is where we're going to use the fact that you know that the common difference between consecutive terms is the same in any arithmetic series. So that means the difference between the second term and the first term must equal the difference between the third term and the second term. Now we've got an equation to solve, and then we can solve this equation to find x. Let's add x to both sides, and plus 3 to both sides, and divide both sides by 2. Oh, that should have been a 22. 19 plus 3 is 22. Okay, so in question 6, x is 11. Yeah. Alright, number 7. Very similar question. Now, form an arithmetic series, find the value of x. So the common difference, so the difference between the second term and the first term must equal the difference between the third term and the second term. So solving that equation to find x, 2 minus 8, and then plus 2, and then you can see we can do this all in one go. 2 minus 8 is negative 6. And then plus 2 to both sides, so you get x is negative 4. Question. Find the first negative term in this series. So we had a similar example to this in the first video when I was asking for find the first positive term. So, but this time you know it's going to be an arithmetic series. How do you know if it's an arithmetic series? Well, because it's got a common difference. So the first term is 98. The common difference is 93 minus 98, which is negative 5. And you can see that that is the same common difference between 88 minus 93 is also negative 5. So this is a arithmetic series, so we know that this is the expression for the nth term. Then we want to find the first negative term in this series. So we want to find when this is less than 0. So let's substitute in. So we've got a is 98. D is negative 5. Oh, let me actually just write that in the front of the brackets, and I'll write it like that, negative 5. Now that's the expression for the nth term. Now we're looking for which one of these terms is negative, the first negative term. So negative means less than 0. So we're going to solve this to find n, and then find what the actual first negative term is. Alright, so Let's maybe move the 98 over to the other side of the equation. Sorry, the other side of the inequality. We're going to divide both sides by -5, and remember, when you divide an inequality by a negative number, you reverse the inequality. So we end up with 19 3/5, and then we get a +1. So n has got to be greater than 20 3/5. And remember, n is an integer, so therefore n has to equal 21. It's going to be the first integer, first integer greater than 20 3/5. So if n is 21, then what is the first negative, what is that 21st term? Well, let's find T21, which represents the 21st term, and hopefully you should get that it is a negative number. So let's substitute in. T21 is equal to A, which is 98, plus n minus 1, so 20 times D. And so that's 98. 20 times -5 is -100, which is -2. Brilliant. Our first negative term in the series is -2. A couple more examples. Last two examples. The first term of an arithmetic series is 7, and the fifth term is 23. Find the 20th term. This is where the questions get a little bit more interesting. So, first term of an arithmetic series is 7, so A equals 7. And the fifth term is 23, so T5 equals 23, which is equal to A plus 4D. Yep, find the 20th term. Alright, so we can use this. We can substitute A equals 7 here to find the common difference, and then we'll have both A and D, and then we can substitute into the nth term formula to find T20. Alright, so let's find D. 23 equals 7 plus 4D. So minusing 7 from both sides, we'll get 16 equals 4D. So D equals 4. So now let's find T20. And that's going to be A plus n minus 1, which is 19, times D. Alright, so 7 plus 19 times 4 is equal to 83. So the 20th term in that series is 83. Alright, so a little bit more problem solving. The fifth term of an arithmetic series is 14. So we're going to write down T5 equals 14. And I'm also going to write down that that is equal to A plus 4D. And then it says, and the 10th term is 59. So T10 is 59, which is equal to A plus 9D. Find the first term and the common difference of the series. Alright, so we've got two equations and we have two variables. How do we solve these? Simultaneous equations, of course. So let's make A the subject in both and then solve them for D. So in the first equation, if we make A the subject, you get 14 minus 4D. And in the second equation, if you make A the subject, you get 59 minus 9D. So if they're both equal to A, that means they're equal to each other. Let's add 9D to both sides. And let's subtract 14 from both sides. And let's divide both sides by 5. So there's our common difference. And then we just need to find A. So we can just use one of our equations that we had. So A is 14 minus 4D, or 59 minus 9D. So 14 minus 4 times 9. So 9. And that is going to be negative 22. So there we have it. We've answered the question. It says find the common difference and find the first term. There it is. That's it for the examples in the second lesson on series.